Hi, my name is Brian Faith, and I'd like to pose the question, are energy beet ethanol viable in the United States? I'd like to start with, what are energy beets? They are a variation of a sugar beet, and while sugar beets are mainly composed of sucrose, energy beets contain glucose, fructose, sucrose, and other inert minor sugars. Now, what makes these very unique is that they grow in a variety of climates and regions all around the U.S., such as the high salinity of coastal regions, as well as the hot, dry, arid regions in the summer and the cold regions in the winters. That goes everywhere from California, where they're already being grown, to Georgia and Alabama, where prospective farms are being thought of, as well as Minnesota and Idaho, where they're being thought to be used in the winter. Another huge benefit to energy beets is that they have long, deep roots. It goes about 8 to 10 inches in the ground. This is hugely beneficial for farmers, especially in that they can rotate it on off seasons, such as in the winters, where in the spring they can still get plentiful harvests due to the nitrogen being brought to the surface, as well as all of the other nutrients that are being risen up when the beets sprout. I'd like to go into a little bit of the production aspect, even though this was heavily covered in class. Just to clarify, energy beets and sugar beet ethanol are very similar, production process that is. There's only minor processing changes that happen throughout the way. Although energy beets can grow, as mentioned earlier, in a wide variety of regions, in comparison to the average sugar beet, it may also be economically feasible in some regions, as well as unfeasible in others, due to transportation limitations and variable and operational costs of plant production and whatnot, which I'll go more into detail in a second. It is most viable as a bioethanol source where existing sugar factories are already in place. This is due to those variable and operational costs, as well as transportation concerns. As of now, there are no set ways to transport these beets and whatnot to conserve sugar. However, there's a study being done by Juan Vargas Ramirez at the University of Nebraska, and him, as well as other graduate students and professors, have discovered that by balancing the pH levels of these beet juices from the, as you can see here, the raw juices that come out of extraction, it can be best for transportation. And so far what they found is over a 6-month period, you can retain 99% of the fermentable sugar, which would be huge if this can be implemented on a larger scale. However, these aren't set yet, and we don't see any plans of this like in the field. If you look here, you can see that after the filtration systems, there are 3 different ways that the sugar beets and energy beets are fermented, and then all being distilled through the same fashion. And after ethanol process and refining, you get bioethanol production. My final, next slide. I'd like to compare these biofuels, mainly all the first generation biofuels, some of which include corn, wheat, cane sugar, as well as the sugar and energy beets. From here, you can see that the energy yield is the highest for sugar beets and energy beets, from 6 tons per acre in sugar beets and 6.3 tons per acre for energy beets, in comparison to the 2.4 tons per acre you find in wheat. There's also much less water needed when it comes to beet production, and it's almost comparable to that of second generation biofuels. In conclusion, I'd like to show carry on throughout. From here you see, although there's no such energy beet to ethanol plants currently in existence, there are sugar beet plants being used in the European Union right now. Almost up to 30% of these production plants are done in the ethanol production. Energy beets also hold advantages over first generation biofuels from the growth regions, the energy density, consumption of water, as well as the low carbon intensity, it being 1/3 of that from wheat and corn production. Thank you. That's my presentation.